Rabbitmq is an open-source message broker software that facilitates communication between different parts of a system, often between distributed systems. It acts as an intermediary that accepts messages from a producer or sender and routes them to the appropriate consumer or receiver. Key concepts of Rabbitmq: 1. Producer: the application or component that sends messages to Rabbitmq. 2. Queue: the message storage within Rabbitmq where messages are held until they are consumed by a consumer. A queue can hold multiple messages and can be configured with certain properties like durability, which determines if it persists across Rabbitmq restarts. The consumer is the application or component that receives messages from Rabbitmq. A consumer subscribes to a queue to receive messages. The exchange is the component in Rabbitmq that routes messages to one or more queues based on certain rules. There are different types of exchanges. Direct exchange routes messages to queues based on an exact match between the routing key of the message and the binding key of the queue. Topic exchange routes messages to queues based on pattern matching between the routing key and the binding key. Fan-out exchange broadcasts messages to all queues bound to it, regardless of the routing key. Headers. Exchange routes messages based on the headers in the message, rather than the routing key. Binding. It's essentially a relationship between an exchange and a queue. It tells the exchange how to route messages to the queue. Routing key. This is a key used by the exchange to create queues. It's mainly used in direct and topic exchanges. How Rabbitmq works. Message production. A producer application sends messages to an exchange in Rabbitmq. The message typically has a routing key. Message routing. The exchange receives the message and routes it to one or more queues based on the routing key and the exchange type. Message consumption. A consumer subscribes to one or more queues and retrieves messages from them. The consumer then processes the message. After processing, the consumer sends an acknowledgement to Rabbitmq indicating that the message has been successfully processed. If no acknowledgement is received, Rabbitmq may re-queue the message to ensure it gets processed. Use cases. Decoupling systems. Rabbitmq allows different components of a system to communicate without being tightly coupled, improving system modularity and scalability. Load balancing. Messages can be distributed across multiple consumers, enabling better load distribution. Asynchronous processing. Producers and consumers can operate independently, enabling asynchronous processing of tasks, which can improve system performance and responsiveness. Overall, Rabbitmq is highly flexible and can be used in various scenarios, such as event-driven architectures, microservices communication, task queuing, and more.